Let's learn how to determine EZ configuration of alkenes. So prior to EZ, we have learned about cis-trans, and for cis-trans naming, we had to have two of the same groups. So for example, let's say I have an alkene that looks like this, and if the two hydrogens on the same side, this was cis, and if the two hydrogens were on opposite sides, such as here, this molecule was trans. However, not all alkenes have two of the same groups, and that would lead to confusion, and that is why we use EZ in our naming of alkenes. So let's say that I have a double bond, and let's say that it looks like this. How do we figure out whether this is E or Z? What you're supposed to do is you're supposed to look at each carbon from the double bond separately. So let's look at this left carbon, forgetting everything to the right. You can just close it with your hand. And you ask yourself, what are the two atoms that this carbon is attached to? So I see that it is attached to iodine and a carbon. We will choose which one is bigger by using the atomic number on the periodic table. Iodine is bigger, and we circle it. Now that we're done with the left carbon, we're going to look at the right carbon, and again, we will forget about the left part of the molecule. You can close it. Now, what is this carbon attached to? It looks like it's just attached to bromine. However, remember that in line angle structures, hydrogens on carbons are not shown, and every neutral carbon wants to have 4 bonds. So this carbon only has 3. That means it's missing this hydrogen, which I'm going to show right now. Between the hydrogen and a bromine, which atom wins? Bromine. Bromine has a higher atomic number. Now that I have circled my bigger groups, I'm going to assign this E or Z configuration. Now, Z is when I have the two big groups on the same side of the double bond. The way you can memorize it is Z is zame, same. That rhymes. So if it's same, if it's on the same side, this is Z. And if it's on the opposite side, this is going to be E. So let's go ahead and check. In order to check, what you could do is you can put a line through the double bond and see if the two groups are on the same side or opposite sides. You can see here they're on opposite sides, so this would be E. Now, sometimes you cannot tell right away what group is bigger, and you may have to go atom by atom until you find a difference. So let's say that I have a molecule that looks like this, and I have a molecule that looks like this. Sorry, it's the same molecule. Okay, so again, what we do is we look at each carbon on our double bond. Carbon on the left. Forget the right side, just don't look at it. Carbon on the left is attached to which two groups? So on the left, I'm attached to bromine, and again, there's a hydrogen missing here. Who wins? Bromine. So this one is easy. On the right, what is this carbon attached to? Carbon, carbon. So far, I see no difference, so I have to keep on going. Carbon here is attached to another carbon. Here it's just attached to hydrogens. It's not attached to another carbon, so this wins. Again, are these two groups on the same side or on opposite sides? And again, these are on opposite sides, so this would be E. And usually these two rules is the most that you need, but I will also show you how to do this with multiple bonds, and then we will practice, which is the most important part of this lesson. So what happens if our double bond, if the carbons in our double bonds have double bonds or triple bond? We will treat them as multiple single bonds. What does that mean? So let's go ahead and say that I have this versus this, and then let's say that I have this, and I have Okay. Now let's again look at the carbon on the left. Carbon on the left, and forget, again, we're forgetting everything on the right side. We're just looking on the left. Carbon on the left is connected to carbon. We're coming from this carbon and we're seeing everything that is connected to carbon, carbon, no difference. Carbon here is attached to two other carbons. Carbon here is attached to only one carbon. So right away, that's the difference. So this wins. Now, let's look at our right carbon, forgetting everything on the left. What is this carbon attached to? It's attached to carbon, carbon. No difference. This carbon is attached to double bond O and a methyl, and this carbon is attached to OH. So how do we do this? Saying that this carbon is attached to double bond O is the same as saying that this carbon is attached to two oxygens. So again, multiple bonds attached are treated as multiple single bonds. If you have C double bond O, is the same as two COs. If you have C triple bond C, is the same as three C single bond Cs. So this will win because carbon, carbon, no difference. This carbon is attached to two oxygens. This one is attached to only one. Again, we ask ourselves, are these on the same side of the double bond or opposite? This time they're on the same side, same zame. So this must be Z. And let's go ahead and get to the most fun part of it, which is practice. So let's look at these two molecules and determine E and Z. You can pause this video, try to do it yourself, and then come back for the answer. Let's get started. So again, what we do first is we identify our double bond and we look at each carbon separately. Looking at this carbon, what two things is it attached to? And we forget this side entirely. So this carbon is attached to carbon, and notice it's missing a bond. It's missing a hydrogen. Carbon, hydrogen, carbon wins. This carbon has hydrogens also. I'm just not showing them to make it quicker. What about this carbon? Bromine, carbon. Bromine wins. So right away we have two winners. Are they on the same side of the double bond or opposite? These are on the same side of the double bond, so this should be Z. And let's go to the next one. Again, we identify our double bond. It's right here. And using colors in organic chemistry is so beautiful and exciting. I highly recommend it. So next we'll look at this carbon. What is it attached to? We forget this part. Again, it's missing a hydrogen because it had only three bonds. Carbon, hydrogen, carbon wins. Again, this has three hydrogens, which I didn't show, but it's okay. Now we'll look at this carbon, forgetting the left side. It's attached to carbon, carbon, no difference. Carbon on the right, carbon here on top is attached to two other carbons. Carbon here is attached to only one carbon. So who wins? This one. Are these on the same side or opposite side? These are on opposite sides. So this should be E.